On question 11, we already have one radical isolated, so we go right into squaring both sides to eliminate the radical that's on the left. So that squaring cancels that radical out, and we have 2y plus 6 equals. However, on the other side, it doesn't cancel that radical because we have a binomial. We have a plus 1. So we actually have a group squared, so we do have to write the group twice, like this. So we need to do some work on the right-hand side, and we got to FOIL this out. So I have the square root of 7 minus 2y times the square root of 7 minus 2y. Whenever you multiply the radical by itself, that is going to just bring out that inside expression because you're squaring it out. Now let's multiply the square root of 7 minus 2y times 1. Well, that's just positive square root of 7 minus 2y. Now we're going to double distribute and bring the 1 in. So 1 times the square root is positive square root of 7 minus 2y. And then finally 1 times 1 is positive 1. So now if we look on this side for any like terms, we have the 7, which I can add the 1 to the 7 and get 8. And then also we can add these radical expressions together since they're the same radical expression. So 7 plus 1 is 8 minus 2y. 1 square root plus 1 square root is 2 square roots, and you never change the inside. So now I have a new radical expression. So we need to work to get this one by itself. So let's subtract 8 from 6, and let's add 2y to the 2y over here. So we can bring those terms over. So 4y minus 2 equals 2 square roots of 7 minus 2y. Now before we square both sides, let's deal with this 2. Sometimes we don't want to divide because the value creates fractions, but on this one it would make sense to divide because 2 goes into both numbers. So 4y minus 2 divided by 2 becomes 2y minus 1, and then we have the square root of 7 minus 2y. So there's an example where division actually does simplify it for you. Now we can go ahead and square both sides to get that radical eliminated. But we end up on the left-hand side with another group squared. So we have to do 2y minus 1 times 2y minus 1 equals, and on this side the radical cancels. We get 7 minus 2y. So now let's double distribute on that side. So that gives us 4y squared minus 2y plus 1 equals 7 minus 2y. Add like terms, 4y squared minus 4y plus 1 equals 7 minus 2y. And now let's go ahead and bring over the terms. So subtract 7 from 1, and let's add 2y to the negative 4y. Set it equal to 0. So we get 4y squared minus 2y minus 6. Now I'm going to divide the whole problem by 2 because I notice I can reduce the coefficients. So that gives me 2y squared minus y minus 3 equals 0. So now what we need to do is factor that using the AC method. And so if I do the AC method, I have my A number's 2, C number's negative 3, so that's negative 6. We want our sum to be the middle, negative 1. So for negative 6, we could do negative 1 times 6, negative 2 times 3, 1 times negative 6, or 2 times negative 3. The 2 and negative 3 is the combination that works. We go back and we rewrite it now as 2y squared plus 2y minus 3y minus 3. And then we factor by grouping. Put plus in the middle, group the last two terms together at the end. Bring out a 2y and we get 2y plus 1. Bring out a negative 3 and we get y plus 1. I made a mistake back here. That 2 actually reduces out, and that makes a big difference there. So that would just be y plus 1 there. So then the two factors are y plus 1. We factor the common group out. The other one is 2y minus 3. So the solutions I get are negative 1 and 3 halves. Then we would need to check those results.